As you can see, I've given you a massive hint for the first question by filling in my favorite letter. I'd like you to choose your favorite letter, use a similar structure, and show how you could represent it. The next question says that images are made up of colored pixels, and if we're only allowed to use 3 bits per pixel, it asks how many colors can be represented. And of course, if you can count, you've probably realized that 3 bits is going to give us 8 colors. The reason for this is it's 2 times 2 times 2, which is 8. You'll want to create a table similar to what you see on my screen. If I want to represent black, it's 0 red, 0 green, and 0 blue. And in fact, when we talk about color, we talk about RGB, or red, green, or blue. So to represent red using 3 bits would be 1 red, no green, and no blue. For green, it would be no red, 1 green, and no blue. For yellow, you'd need to realize that yellow is combined of red and green light. So to represent yellow, I'd need 1 red, 1 green, and no blue. Cyan is a combination of blue and green, and magenta is a combination of red and blue. White is equal combinations of all of our colors, so to represent it would be 1, 1, 1. Of course, in the real world, we have a lot more than 8 colors. It's common to represent color using something called 24-bit color. This is where we have 1 byte to represent red, 1 byte to represent green, and 1 byte to represent blue. A reminder that 1 byte is 8 bits, so 3 bytes is 24 bits. I'd like you to see if you can work out how many colors can be represented using 24 bits. The next question asks if we have an image that is 100 pixels wide by 100 pixels high, how many bits would we need to represent it using 24-bit color? To figure out the answer, we'd need to say 100 times 100 to get the number of pixels, and then multiply that by 24. I'm going to actually stop this video at this point, and in the next video, I'll give you a worked example for questions 5 and 6.